Hey, it's Midge. I made Minesweeper in Godot. This is that story. I publish games as Midge Makes Games. Gun Night All Day was my last big original project that is available on Steam. This video is on Minesweeper in Godot. This is my second Godot learning project. Previously I had done Solitaire. Solitaire and Minesweeper are both available for free on itch.io. Why Minesweeper? Why this project? The realist reason is when I started Minesweeper, I hadn't really decided what I wanted to do for my next big original project. This seemed like a good way to apply what I learned with Solitaire and keep the momentum going. Solitaire took a little longer than I planned. A little project that lasted months. I wanted to make something that I could finish on a shorter timeline. Minesweeper seemed like a good fit. And also, I'm just plain enjoying Godot. It's new enough to me that I've still got a lot to learn, and it's fun.
Because I like it.
So Minesweeper is a logic puzzle game. The origin of the game, according to Wikipedia, is a little unclear. It was popularized by Microsoft, and it sounds like they were inspired by a game called Mined Out. I first saw the game as a kid on Windows 3.1. When I hear mine, my first thought would be something like a landmine, something like this. Oh. But the depiction of mines in the game are naval mines. A minesweeper is a type of boat used for removing or detonating naval mines. The game is kind of weakly themed. There's no water background or boats or anything like that, but the name and depiction of the mines suggest naval mines, not land ones. Maybe this was obvious to everyone else, but I didn't think about it much until I made the game. And at the end of the day, it's a logic game. There's a grid. You have to determine which tiles are mined and not accidentally detonate a mine in the process. Okay, so a quick description of the gameplay. You have a grid of tiles that start off blank, hiding what's underneath. We'll call them unrevealed tiles. These tiles may be empty or they may contain a mine. Each reveal tile will have a number for the number of adjacent mines, max number of 8, minimum number of 0. To reveal a mine, you left click on it. To mark a tile as mined by adding a flag, you right click. You can right click once more to change that into a question mark for tiles you aren't sure about. If you left click onto a mine tile, the mine explodes and you lose.
You go to hell! You go to hell and you die!
The win condition is you have revealed all the tiles without mines. So shortly after I posted my version of Minesweeper online, someone mentioned the joke website One Square Minesweeper. As described, there is only one square, and yes, it always contains the mine. I know it's a joke, but in reality, if you've implemented a single tile or square, you're well on your way to being done. You just repeat that tile a bunch of times, and that's a great starting point. Minesweeper was an appealing project to me because it wasn't super intimidating. You implement one mine tile and repeat that tile as needed.
And scene.
Scenes overview. We are in Godot for this project, and we're using scenes. There are only 2 scenes in this project, only 2 scripts. We have a main scene. This contains all the top level things and the grid for the mine tiles. And then we also have the mine tile scene. We make one of these for every square in the grid. I think with Solitaire, I broke things up a little more than I needed to, sometimes overcomplicating communication between nodes. I kept it simpler with this one. 2 scenes, each scene has its own script. That's it. Okay, so a single tile, how do we implement it? Looking at the old Windows Minesweeper, it's obvious that each tile is a button. So in Godot, we'll be using control nodes, just like I did for Solitaire. I call each tile a mine tile. We learned in Solitaire that later siblings in the node hierarchy show up on top. So we'll be using that to make sure everything shows up in the correct order. Let's talk about the different possible states of a mine tile. A tile can be revealed or unrevealed. An unrevealed tile will have a top-level gray button showing. A reveal tile would show a mine, a number, or a blank space if the number is 0. An unrevealed tile can be marked in a few different ways.
Oh, hi, Mark.
It could not be marked, so just blank, or it could be flagged, or it could have a question mark on top. So it could be no mark, flag, or question mark. Once a tile is revealed, it can no longer be marked. A mine tile can have a mine. This is just a Boolean. It has a mine or it does not. A mine tile also has an integer number to reflect the number of adjacent mines. Max value of 8, min value of 0. We'll worry about correctly populating this number later. We talked about the mine tile states. Now let's talk about their presentation. There's a button. That's just a plain old button. There's a mine image. This goes under the button and gets shown if a mine is triggered. I used a texture rect for the mine image, so I actually drew an image for the mine. There is the adjacent mine number. This is the number that shows up underneath the mine button. If the value is 0, we hide the number. If the value is 1 through 8, we show the number. We also set the color of the number based on the value. For marking tiles as flagged, I used an emoji. I didn't want to draw a flag, and a flag emoji already existed, so I just used this. This felt like a smart shortcut, but it did cause some problems later on. So this is a text label with an emoji. Question mark displays just plain old text, so this is also a label. I had a different label for the flag and question mark. Instead of setting the value in code, I just showed the appropriate node conditionally.
Conditional is better!
One pattern I use for most of these states is properties, getters and setters. So I have some backing value in lowercase and some uppercase property for the value itself. The getters are simple, they just grab the backing value. The setters will, surprise, set the value, but they also handle refreshing the display as well. This might be logic for deciding which nodes to show for marked nodes, like a question mark or a flag. This simplifies the logic a lot for me, and I used it all over the place. All right, so we talked about the mine tile scene. Now let's talk about the other scene, the main scene. This is the first scene to load, and it's the one that instantiates the grid of all of the mine tiles. The main scene is also the place where we show all the game state, the flag counter, the timer, and the button with the smiley face to start a new game, or skull to show that the game is over. The grid is a little interesting. This is where we spawn in all the tiles. The grid controls a node predictably of the same name, grid, and it's super useful. You just have to set the width for the number of mine tiles across. Communicating from the mine tiles to the main scene and vice versa can be a little tricky. When an event happens in a mine tile, I wanted the mine tile to know which tile it was. And the simplest way for me to do this was to just give it an index number, starting at 0 and increasing. This is assigned at instantiation of the grid and never changes. There are 3 difficulty levels: beginner, intermediate, and advanced. These will all generate a different size grid with a different preset number of mines, but early on in development I didn't implement this. I just focused on the beginner one and got things working there. The new game button, I also used emojis like the flags. I like this because it felt like a shortcut. I didn't have to draw the faces, I could just use built-in emojis. Yeah, the main scene was pretty easy stuff that I added to iteratively as needed. Detecting input. What input specifically do we need? Let's make sure we can detect it. When you have an unrevealed tile, left button pressed event will reveal that tile. So that's when you release the left mouse button. Pressing down on the button, moving the cursor off the button, and releasing it will not reveal the tile. For this, we can use the regular button pressed events. Easy peasy. Okay, so now we'll talk about marking the tiles. Marking as in adding a flag, a question mark, or clearing a question mark. This is the right click. It's also not press, it's mouse down. I know this from reverse engineering the other Minesweeper games online. For this one, I used the on button GUI input, and then a filter for the right mouse button press event to make sure we just catch the right mouse button downs. This was harder than I expected for getting a right mouse button down, but not that bad. For reveal tiles, I added a feature later where you can click on the number. So there's an invisible button underneath the regular mine tile button as well. We'll talk about that one later. Input.
You can't handle the
Input. We can detect the input, so let's start handling it. Starting with mine tile right click. We're starting here because this is the easiest of the clicks to handle. So a right click on an unrevealed mine tile will add a flag. Another right click will add a question mark, and a right click on the question mark will clear the mark. So I have an enumeration for the flag value. The flag value can be none, flag, or question. What I do is I just increment this by 1, and I use a modulus operator so it wraps back around if it goes over the max enum value. Because we also have a flag counter in the main scene, we need some logic to adjust the flag count in the main scene when the marking changes. If we add a flag, we decrement the count. If we remove a flag, we increment it. Question marks don't count towards the flag count. So if the player left clicks on a mine, the mine explodes and they lose. Let's handle that. Fun fact, in my version of the game, you cannot lose on your first click. I don't place any mines until after the player reveals their first tile. So each mine tile has a boolean to let us know if the tile is mined. We check that value. If it's true, explode. If we had an explosion, we then change the mine image. There's a special mine image with a red background to show the player which mine exploded. Then we go to the main scene and change the game state to a loss. The smiley face will turn to a skull, but briefly we change it into a surprise face for like 200 milliseconds as a little bit of game juice. Now the game is over, we need to disable the input on all of the mine tiles. I used a group to do this. The main script calls the group and tells all the tiles to disable their input. Then I show all of the unrevealed mines. but of course without the click logic because the game is already over. Also, we need to stop the game timer. If the player wants to start a new game, they can click on the big button up top, which now displays a skull. Handling left click for tiles without mines. So the player has clicked on a tile without a mine. What now? First off, we reveal the tile, hiding the button to show the number underneath. The number I'm talking about is the adjacent mine tile count. This number was assigned after all of the mines were placed following the player's first click. Remember, we did that so the player wouldn't lose on the first click. If the adjacent mine tile count is greater than 0, cool, we've revealed the tile. Now we can check the win condition. The win condition is all non-mined tiles are revealed. But if you've played Minesweeper, you know there's another case. If the adjacent mine tile count is 0 and the number is hidden, more than one tile may be revealed. This was probably the hardest part of this project, if I'm being honest. It's not too bad, but revealing the empty tiles took a little bit of thought and some experimentation. Revealing 0 tiles. Revealing 0 tiles has some complexity. This problem could be solved by recursion, but honestly, sometimes recursion feels like it breaks my brain. My solution was iterative. So my approach was build up a list of tiles to visit. These are going to be adjacent, unrevealed, 0 number tiles. Then visit all of these tiles, repeating the procedure for getting adjacent, unrevealed, 0 tiles to that tile. The idea was just to maintain that list, and as long as there is still something in the list, remove that tile from the list and work on it. My naive approach kind of worked, but I did notice sometimes it seemed slow, even on the small size grid. When I tried medium and large size grids, there were problems. It just hung the game out to lunch. I knew this was a problem that needed to be fixed, but I decided to defer it. An algorithmic rework might be some trouble, so I just wanted to come back to it later. So in the meantime, I made the rest of the game. I focused on changing the game state, things like starting a new game. I used a call group when starting a new game to tell all of the mine tiles to reset to start state. That sets everything back to unrevealed and removes all the mines, sets all the adjacent mine count numbers to 0. Then we wait for the player's first click to place the mines and set the mine count numbers on all the tiles. I implemented different grid sizes for different difficulty levels as I continued poking at the 0 tile reveal problem. One thing about Solitaire that people complained about was on 4K screens it looked kind of tiny. It didn't scale up. So I added a nice little scaler that scales everything up so people on 4K screens can change the size if needed. Revisiting the empty tile problem. Revisiting is an appropriate title for this section because it turned out the fix was pretty simple. The fix was to avoid doing redundant work by revisiting the same tiles multiple times. I was afraid I was going to have to rewrite a lot here and really put on my thinking cap, but that just wasn't the case. I just had to avoid that redundant work. So I maintain a list of tiles to visit, just a list of integers because remember I gave each tile an index number. So the to visit list is all of the tiles I have to go to check for adjacent unrevealed 0 tiles. I would take one off the front of this list for each iteration of the loop. For the current position in the list, I would have an append list, which would be all of the tiles we might add to the to visit list from this iteration. So the fix was just checking each integer in the append to list and seeing if it was already in the to visit list. If it was, we skip it. If it was not, then we could add it to the to visit list. This did the trick. Nice and speedy, no more problems. Feeling pretty good about the project and thinking I was almost done, I decided to test out a deploy to h.io. But we had problems. Remember, I had decided to use emojis for the smiley face and skull main button and also for the flags. This worked great locally. I could use emojis instead of images, but on h.io, they were missing.
Thanks, Obama.
I had some weird character codes showing up, not the desired emojis. I could either replace those emojis with images that I'd have to either find or make the emojis work. I decided to make the emojis work. So the problem was a missing font file. I found a free and open source font file from Google and I added that to the project. It's a little ridiculous because the game itself is tiny and the font file is like 15 megabytes, like a moped towing an 18-wheeler trailer. But whatever, it worked. H compression made the font file a little smaller, I think, but computers are fast. It works now. After fixing the emoji deployment issue, I made the game public on HIO and I told the world about it. I swear it took about 5 minutes before someone told me I needed to add the question mark. So I fibbed a little bit earlier when I said I designed the game with the question mark in mind. I didn't have it in the initial release. I reverse engineered the game from an online version and it wasn't in that version. And I didn't really use it when I played, so I just kind of forgot about the question mark. So I added the question mark. A little while later, I got some more feedback. I was missing the ability to click on a number. I did not know what this guy was talking about. I had never heard of this feature or used it, so I looked into it. Clicking on a number. Let's say you have a revealed tile, no mine on this tile, so we have a number. If the adjacent 8 tiles have a flag count equal to that number, and then you click on the number, all of the unrevealed tiles that are not flagged will be revealed. If you flagged incorrectly, it will reveal the mine and you lose. This is a gameplay optimization. It can really speed things up for the player. Cool feature I did not know about when I started the project. Also, when you click on the number, the adjacent unrevealed tiles mimic the button press to show they are affected. You push on the number, those adjacent unrevealed tiles act like you are pressing on them. You could see them get pushed if the flag count did not match the number. Faking the press was a little tricky. I didn't want the identical logic as a button press because the logic wouldn't get triggered if the flag count didn't match the number. It was cancelable. Fortunately, there was a built-in method for faking a button press. Set pressed, no signal. Once I found that in the documentation, the problem was trivial. The logic was simple to implement after finding this way to fake the button press on the adjacent 8 unrevealed tiles. So now we had the number click feature. So I released an updated version with the question mark and the number click feature. All done. The whole project was pretty quick and I was quite happy with it. There's a link to Minesweeper in the video description. Check it out if you're interested. Like Solitaire, it does not play on mobile. It's desktop only. I hope you enjoyed the video. Like and subscribe if you want to see more of my projects. Thank you for watching.